Now let's see the convolution problems where any one or both the signals are infinite in nature. Infinite in the sense they run from minus infinity to plus infinity, or from 0 to infinity, or from any fixed value to infinity. Now let's take the very first problem, a simple one. Y of n is equal to u of n convolution with u of n minus 3. Among these, we can consider one as x of n, the other one as h of n. Even it could be in a reverse way also. X of n can be u of n minus 3 and h of n can be u of n. Now here we follow 4 steps. The very first one is drawing. So x of n is nothing but u of n. We all know how u of n signal is. It's a train of unit samples. So running from 0 to infinity. And from minus infinity to minus 1, it is 0. Now similarly, let's draw the h of n signal. H of n is u of n minus 3 signal, wherein the u of n minus 3 starts from 3 onwards. So plus 3, 4, it runs up till infinity. Now in this, we need to follow the first step as the indexing. Indexing means changing the variable, because we know that the convolution y of n is equal to this equation, and in this equation we have x of k and h of n minus k. So we have to get this x of n and h of n minus k, means h of n has to be brought to this form. So x of k is obtained by indexing. Changing the indexing means changing the variable. X of n will be replaced by k. So wherever there is n, we need to place it as k. So x of k is nothing but u of k. The same signal, nature of the signal will not change, just the variable changes. And similarly, h of k, same signal, just with a indexing. Then in this, to solve this equation convolution, we need just x of k, but h of n minus k is required. So we have already x of k, we don't have to do anything with x of k, but we have to obtain h of n minus k. So h of n minus k signal, h of n minus k signal is obtained in this way. H of n minus k signal. So we all know the time reversal property of the signal. H of n minus k means, by considering, let's say if n is 0, then the value of the signal becomes h of minus k. So h of minus k is nothing but the reversed version. So the signal was starting from 3 to infinity. Just when we fold it, when we reverse it, so it runs from minus infinity to minus 3. So this will be h of n minus k, h of n minus k signal with n is equal to 0. Now here n is a variable and n can take any value from minus infinity to plus infinity. So when n is positive, the signal h of n minus k signal runs. H of n minus k signal will be moving. When n is positive, it moves to the right. When n is negative, the signal will be moving towards left. So n is a moving variable. By choosing the particular value of n, we can move this h of n minus k either left or right. If n is positive, towards right. If n is negative, the signal moves towards left. Now, here the value of n is 0. Now, The convolution is nothing but this equation. It's x of k, h of n minus k. It's nothing but the product of x of k signal with h of n minus k signal. And to find the product, and we all know that to have the non-zero product, the signal should be overlapping. Means for the same value of k, both the signals should exist. If any one of them is a 0, then the multiplication becomes 0. So now this is our x of k and the same signal h of n minus k. H of n minus k with n is equal to 0 is this. Now if we see this h of n minus k signal and x of k signal, this x of k starts from 0 and runs up till infinity, wherein the h of n minus k signal is there from minus infinity to minus 3. Means one is on the left side, the other one is on the right side. X of k is on the right side, h of n minus k is on the left side. And if we see minus 2, it is ending at the h of n minus k, and the x of k is starting at 0. So at none of the values, for any one of the value, like for no value of k, the signals, both of these signals have the value. So for same value of k, both the signals are not existing. If it is from minus infinity to minus 2 means for these values, the h of n minus k is existing, but wherein x of k is not existing. And on the other side, from 0 onwards, x of k is existing, wherein h of n minus k is not there. So the product right now, if we see, they are not overlapping with each other. As they are not overlapping with each other, so the product of those is certainly 0. Now we need to find where, like by what value, or by choosing what value of n I can make this multiplication like non-zero. Now it's clear that when n is taking the negative values, this h of n minus k signal is going to move towards the left. And as it moves towards the left, certainly we are increasing the gap. One signal is on this side, another signal will be on this side. As the gap increases between these two, and there is no possibility of multiplication. In the sense, no non-zero multiplication exists. So it is always 0 as long as I choose the value of n as negative. Now, as I know for negative values of n, y of n is certainly 0. I think of taking the positive values. When n is 0, the h of n minus k is this. When n is 1, the signal becomes this way. So here it is ending at minus 3, but in this, when n is 1, it runs up till minus 2. 1 value, right side it comes to. So it is just imagine that a pulse train is coming or jumping 1 unit to the right. So it will be coming up to minus 2. If I consider n as 2, then what happens? Then this signal will be coming 2 units to the right. When it is coming 2 units to the right, certainly it comes up till minus 1. But still, the signal is ranging from minus infinity to minus 1, and wherein x of k is running from 0 to infinity. So still they are not overlapping. Now let me take the value of n as 3. When I take the value of n as 3, this h of n minus k signal, wherein minus 3, it is starting at, this sample comes at 0. So the signal h of n minus k with n is equal to 3 is in this way. Then I can take the value of n as 4 and so on. Now it's clear that at n is equal to 3, I have a sample at 0 and x of k is having a sample at 0. Now this 0th sample and the h of n minus k with n is equal to 3 having the sample at 0. So y of n will have its value as non-zero because both the values are existing for a particular value of k. Now after this, when n is equal to 3, multiplication starts existing. When n is equal to 3, it's possible. When n is equal to 4, my h of n minus k signal will run from minus infinity to 1. So x of k is the same one running from 0 to infinity. Now the 0th sample is having its pair. So here at k is equal to 0 also the multiplication is possible, and at k is equal to 1 also x of k is having a sample and h of n minus k is also having a sample. So the multiplication starts existing. Now here also when h of n minus k is equal to with n is equal to 10, then our first sample means on the right side will be there at 7. Likewise, we can take any value for n. So if n is equal to 10, it will be 7. It is anyhow whatever the value of n is there minus 3 to it. If n is 3 here, it is 0. If it is 4, it is 1. If it is 5, it would be 2. Then if n is 10, then it is 7. So in this way, we can take any value for n. Now, what is the conclusion? The conclusion is y of n, the result of convolution, is 0 as long as my value of n is less than 3. Or even we can write n is less than or equal to 2 also is okay. So as long as n is less than 3, my y of n is 0. But when n becomes greater than or equal to 3, when n becomes greater than or equal to 3, then certainly my h of n minus k starts coming towards the right side wherein x of k is lying within. Now as I choose more values like higher value of n, more this h of n minus k starts coming towards the right and more number of samples get multiplied. Now the result of the convolution is y of n is equal to summation k is equal to 0 to, okay, I'll explain this one. It is nothing but u of k, whatever are x of k and h of n minus k are there. Now this below limit, the lower limit indicates from where the convolution starts beginning. Means even though k is equal to minus infinity and all we write, but for this problem, the overlapping starts from where our x of k is starting at 0. Means before 0, even though h of n minus k is present, x of k is absent. So when h of n minus k starts coming towards the right, then only the multiplication is existing. So the starting limit becomes 0 because before 0 we can't have or we don't have the multiplication happening. So multiplication begins from 0. Okay. Then from up till what? If my n is equal to 3, it is 3. Means only one sample gets multiplied. If my n is 4, then 1 and 2 means higher range is 1. For n is equal to 4, it is 1 means 0th sample and first sample, these both get multiplied. If my n is equal to 10, then 0th, first, second and so on up till 7. These all from 0 to 7 samples get multiplied with x of k signal 0 to 7. So likewise, always if it is 3, then 0. If it is 4, then 1. If it is 5, then it would be 2. This way. So starting limit of my convolution is 0 So ending would be n minus 3. So let's write, we need to write it in general because we can't write it for a particular value. So whatever may be Rn, if n is 2 or n is 3, then of course it is from 0 to 0 only. If n is 4, then 0 to 1. If n is 5, 0 to 2, like this. So u of k, u of n minus k. We know that u of k is a unit sample, and similarly u of n minus k, the amplitude of both of those are just 1. So we have a summation with some lower limit and upper limit with a value 1. And whenever we have this kind of a situation in mathematics, when summation is having 1 and having some lower and upper limits, then its output or its value is given by upper limit minus lower limit plus 1. So similarly, the output, the value of the summation is upper limit minus lower limit, which is 0, then plus 1, so which is n minus 2. So our output is, the output y of n is, so we know that as n is less than or equal to 2, or we can say when n is less than 3, the output of our signal or the output is 0. So when n is equal to or greater than 3, the output starts existing. So n minus 2, we have to take the value of n as 3 or greater than 3, any value. So when n is equal to 3, when n is equal to 3, 3 minus 2, which is 1. When n is 4, it is 4 minus 2, which is 2. When n is 5, it is 5 minus 2, which is 3. So in this way, generalized, the output waveform can be represented. So this is regarding the discrete time convolution. So keep on solving this kind of problems and let me know if any problem is there. Thank you.